Hello and welcome to another session in physics. In this session we'll be looking at an AC circuit containing only inductor and resistor. But before that, let us review the previous lesson. Welcome back. Well, for an AC circuit containing an inductor and resistor, we call it an LR circuit, which is an inductor resistor circuit, and it is given by impedance LR, which is equal to the RMS voltage over the RMS current. RMS voltage over the RMS current, which is also given by peak value of the voltage divided by peak value of the current. Alternatively, the impedance is also given by the square of the resistor plus the square of the inductive reactance. And the current in an LR circuit, the current here is I, and it is given by the peak value of the voltage divided by the square of the resistor plus the inductive reactance. In other words, peak value of the voltage divided by the impedance gives us the current. And then the angle of the applied voltage tan theta is given by voltage across inductor over voltage across resistor. Voltage across inductor over voltage across resistor. And the effective or total voltage is given by this squared, voltage across resistor, plus voltage across inductor squared. You find the square roots of them. Now let's talk about an AC circuit containing only a resistor and a capacitor. AC circuit containing a resistor and the capacitor is called an RC circuit. Now this RC circuit also gives us impedance, and it is given by the RMS voltage over the RMS current, which is also given by the peak value of the voltage over the peak value of the current. Subsequently, the impedance is also given by the square root of the resistor squared plus inductive capacitive reactance, rather, because we're talking about the capacitor and the resistor. Capacitive reactance squared. And the RC current, I, the RC current I, of course, it's the peak value of the current. It is given by the peak value of the voltage divided by the impedance, the RC impedance. And then the effective or total voltage in an RC circuit is given by voltage across the resistor squared plus the voltage across the capacitance squared. And of course, the angle of the applied voltage, the angle of the current on the applied voltage tan theta is given by voltage across capacitor over voltage across resistor. Voltage across capacitor over voltage across resistor. Yes. At this point, let's talk about AC circuit containing only inductor and capacitor. AC circuit containing only inductor and capacitor. Well, inductor and capacitor is given as LC circuit. But for an LC circuit, the impedance for an LC circuit is given by the RMS voltage over the RMS current. It's also given by the peak value of the voltage divided by the peak value of the current. Subsequently, the impedance is given by the square root of the inductive reactance minus capacitive reactance, both of them squared, which gives us the inductive reactance minus the capacitive reactance. The current in an LC circuit, the current here, which is the peak value of the current, is given by the peak value of the voltage divided by the capacitive reactance minus the inductive reactance, both of them squared, which gives us the peak value of the voltage divided by the inductive reactance minus the capacitive reactance. Also, the effective voltage V is given by the voltage across inductor minus voltage across capacitor squared, which is equal to this by method of factorization. Now let's look at the AC circuit containing three of them now, containing an inductor, resistor, and a capacitor, which is called an RLC circuit. It is called an RLC circuit. Now, for this particular circuit, it is more like a unified circuit of resistors, inductors, and capacitors together. So it gives us the actual impedance Z, which is also equal to the RMS value of the voltage by the RMS value of the current, the value of the voltage divided by the value of the current. Also, the Z is equal to the square root of the resistor squared plus the inductive reactance minus the capacitive reactance squared. And of course, the phase angle of the current, theta is given by tan theta equal to the voltage across inductor minus voltage across capacitor all over voltage across resistor. And that's it for the phase angle. Then the effective voltage is given by square root of voltage across resistor squared plus voltage across inductor minus voltage across capacitor squared. At this point, let us talk about resonance in an AC circuit. Resonance in an AC circuit. Now, when we talk about resonance in an AC circuit, we are talking about the frequency. We're talking about the frequency at which resonance frequency occurs. The frequency at which resonance frequency occurs is known as resonance in an AC circuit. And this occurs when the voltage across inductor is equal to the voltage across the capacitor. So resonance frequency F with subscripted O is given by 1 over 2 pi and the root of inductor times capacitor. At resonance, the maximum current I is given by V over I from Ohm's law. It's given by V over I from Ohm's law. At this point, let us talk about the power in an AC circuit. Power in an AC circuit. Now, when we talk about power in an AC circuit, of course, remember that from the power equation we have P equal to IV. Now, the average power in an AC circuit, P is equal to IV cos theta. Cos theta is there because an angle is involved. You can say P equal to I squared R. P equal to I squared R, where I is equal to root mean square current, which is IRMS. And then we have V, which is root mean square voltage, which is RMS voltage. And then we have theta, which is the phase angle of the current. Phase angle of the current. If you don't want to call it phase angle, you can call it angle of lag. Angle of lag between I and V. Between current and voltage. So cos theta gives us the power factor of an AC circuit. The power factor of an AC circuit is given by resistance over impedance. resistance over impedance, which is equal to R over Z. Let's take this very simple question. It says that the power dissipated in an AC circuit has an RMS current of 5 amperes, RMS current of 5 amperes, and RMS voltage of 10 volts. RMS current of 5 amperes and RMS current of voltage of 10 volts, and phase angle theta of 60 degrees. And we're asked to find the power dissipated in the circuit. So the power dissipated in the circuit is going to be given by B equal to IV cos theta. So we have our I as 5, our V as 10, and times cos 60, which is the phase angle of the current. When you do your calculations very well, everything is going to give you 25 watts. Of course, watts is the SI unit of power. Thank you so much for joining us in this lesson, and do make sure to go through the notes attached at the end of this video. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.